Hello to all. I am Dr.AJAY Kumar Sinha, Professor of Chemistry. Today I am going to discuss octane number and unleaded petrol. Octane number and unleaded petrol. Here, before going to depth, before going to octane number, I want to tell what is actually petrol. Petrol, actually this is the organic compound known as hydrocarbon, means compound of carbon and hydrogen. And in petrol and diesel and kerosene, how they differ, then they differ in number of carbon atoms present in them. Hydrocarbon, in hydrocarbon, all are hydrocarbon. What I discussed now, that is a petrol, diesel, kerosene, heavy gas oil, paraffin, all are hydrocarbon, means compound of carbon and hydrogen. Then they differ in the number of carbon atoms present in them. Then if composition of hydrocarbons, means if it is a carbon number 1 to carbon number 4, if hydrocarbons are having number of atoms between carbon number 1 to carbon number 4, maybe 1, maybe 2, maybe 3, maybe 4, it means C1 to C4, then it is used, this hydrocarbon actually is used as domestic LPG fuel. This is actually gas. See, hydrocarbon which has number of carbon atoms between 1 to 4, that compound, that hydrocarbon is called gas actually. Gas, which that gas is used in domestic LPG, fuel synthesis gas. Its main use is there. If number of carbon is between C5 to C6, C5 to C6 means carbon number 5 to carbon number 6, then that fuel is used as petrol. Fuel, this is also called petroleum ether. Petroleum ether. And it is used fuel for petrol engine. Petrol engine. Or also you can tell fuel for petrol engine, aviation spirit. And when carbon number is hydrocarbon having carbon number 11 and 12, C11 to C12, then that is called kerosene. Kerosene. And use of kerosene is well known. It is used in domestic fuel for illumination and heating jet fuel. And if carbon number present is between C13 to C17, C13 13 to C17 17, if number of carbon atoms are present between 13 to 17, then this is called actually diesel. Diesel, also called light gas oil. Light gas oil, fuel for diesel engines and furnaces. And like that way, this is the light gas. Heavy gas oil is carbon number 18 to carbon number 25. Carbon number, hydrocarbon containing number of carbon atoms between 18 to 25. Then this is called heavy gas oil. And it is used for fuel for generating stations, means as a lubricating oil. Lubricating oil, also you can tell cracking stock. And if number is more, carbon number is between 25 to 40, that is called paraffin. Paraffin. If carbon number is between C25 to C40, C means carbon, then this is called paraffin, and it is used in waxes or candles. Okay, wax papers also, it is used in wax paper, matches it is used. And this if again further it is more number of carbon atoms, then that is actually it will be in the solid form, that is called asphalt, solid residue, asphalt, and this is used as a surfacing road, roofing, petroleum coke, coal tar, what we are telling, all things are coming, that is the solid residue, asphalt. Correct? Then this I have discussed about the, you can say, petroleum products, and all these are separated according to the boiling temperature. All these products have different boiling point. They will boil in different temperature. As for example, first what I discussed, that is a C1 to C4. Its boiling point is up to 20 degrees centigrade. Only 20, up to 20 degree maximum. And second, that is the petroleum ether, means petrol, also called gasoline. Petrol is also called gasoline. Then its boiling point is between 20 to 70 degree. 20 to 70 degrees centigrade boiling point. And kerosene, that is C11 to C12, its boiling point is more, 180 degree to 230 degree centigrade, because number of carbon atoms are increasing. As the number of carbon atoms will increase, boiling point will increase. Then first you have seen, when carbon number was less, boiling point was less, maximum up to 20 degree. And when it was C5 to C6 in petrol, also called petroleum ether, its temperature, its boiling point was between 20 to 70 degree centigrade. And kerosene, now C11 to C12, then its boiling point is very high, 180 to 230 degree centigrade. And for diesel, when carbon number is C13 to C17, it is called as a light gas oil, and its boiling point is 230 to 305 degrees centigrade, very high, more than kerosene, 230 to 305, because number of carbon atoms are more, C13 to C17. And heavy oil, that is we are telling lubricating oil, then this its melting point is further high, because now carbon atoms are C18 to C25, and its boiling point is 305, between 305 to 405. Like that way, paraffin, C25 to C40, number of carbon atoms are very high. Now it is in a solid form. As the number of carbon atoms will increase, it will be solid, from gas, then liquid, then solid. And there is no question of boiling point. Boiling point is for liquid, but for solid, melting point. For solid, always melting point. Then its melting point is there, but low melting point, because when it will melt, it will convert to liquid, and then it will boil. Then it has a low melting point. Okay, and paraffin is used in wax paper, matches, candles. Okay, in backstage also there it is used. Then this I have discussed about the I can say petroleum products, and all are separated by the use of fractionating column. Fractionating column. Actually, from the crude oil, it is separated by the use of fractionating column. Okay, that is called fractionation of petroleum, crude oil. Okay, from the crude oil, all these products we are getting. Now come to the octane number. What is actually octane number? It is very, very important. Octane number of fuel. What is this? Then now I am telling you. The gasoline means a petroleum, a petrol I am talking about. The gasoline is also called petrol. The gasoline vary in their resistance to knocking. You might have observed that in motorcycle or in car sometimes a sound comes from the engine. That is due to knocking, just like door knocking. Here, that is the petrol when it burns, then there are small particles just like a sand. It will just on the walls of the engine, it will attack. Okay, it will strike there, and then sound comes. That is called knocking. A striking of small particles like a sand on the walls of engine. That is called knocking. Then the gasolines vary in their resistance to knocking. Okay, in order to evaluate their quality, when which you can say petrol will knock more or less. Knocking is not good. Okay, knocking means it will harm the engine, internal combustion engine. It will harm. Then that is a good quality of petrol will not knock too much. Okay, the gasolines vary in their resistance to knocking. Good quality of petrol, it will not knock too much. Okay, that's why it will resist. Then the gasoline vary in their resistance to knocking. In order to evaluate their quality, an arbitrary octane scale was developed by measuring their knocking characteristics. Octane numbers of gasolines are simply defined with reference to normal heptane. Normal heptane is organic compound, that is a hydrocarbon, C7H16. Carbon is 7. C7 is carbon atom is 7. Hydrogen is 16. C7H16. It is called normal heptane. 7 means heptane. 7 carbon means you are talking about heptane, alkane. Then octane number of gasolines are simply defined with reference to normal heptane and isooctane. Isooctane means C8H18. Carbon number is 8. These two are considered as standard. With reference to normal heptane and isooctane, octane numbers of gasolines are defined. The straight chain hydrocarbon, normal heptane is a straight chain. See, all carbons are joined to each other in a straight way, and with that carbon, hydrogen is joined. With each carbon, hydrogen is joined. They are making bond with carbon. The straight chain hydrocarbon, that is a normal heptane, which has poor combustion characteristics. Poor combustion characteristics. It will not burn quickly. Poor conduction characteristics and knocks badly, is arbitrarily given an octane number of 0. octane number of 0. Its value is given 0, simply, arbitrarily, without any rhyme and reason. Simply its value has been given octane number as a 0. Whereas the branched chain hydrocarbon, branched, it is not a straight, branched, means one carbon is joined with other carbon, and again other carbon will join with other carbon. It's not a straight, it is in a branched form. Then whereas the branched chain hydrocarbons, that is called isooctane, its name is 2,2,4 trimethyl pentane. 2,2,4 means what? At carbon number 2, another carbon is joined as a methyl group. Carbon number 2,2,4 means carbon, it is telling about the carbon number. Carbon number 2, carbon number 3, carbon number 4, like that way. Then branch is at carbon number 2, means with carbon number 2 other carbon is joined. Generally it will be hydrogen only. With carbon, hydrogen will be joined, only with one bond will be there with a straight chain, carbon will join. But branch, only hydrogen will, no branch. But here in branch chain, carbon will join. That's why only it will form branch. Then its name is that is the isooctane. That is also called, it is branch chain hydrocarbon, isooctane. And its name is 2,2,4 trimethyl pentane, which has an excellent combustion characteristics. It will burn very good way, very quickly. Excellent combustion is burning. Then this 2,2,4 trimethyl pentane, that is the isooctane, has an excellent combustion characteristics and very little tendency to knocking. And its given, and its value is given an octane number of 100. Its octane number is given 100. 100 means normal heptane, which is bad, its value is given 0, octane number is 0. And for isooctane, its octane number value is given 100, means very good, best, excellent, you can say these things, characteristics of petrol or gasoline. Okay. Then octane number of gasoline, how you will define? The octane number of gasoline is the percentage of volume. Actually it is a mixture of both octane and isooctane mixture. Suppose you have mixed both octane and normal heptane and isooctane you have mixed together. Suppose it is 100 ml. Just simple for explanation I am telling you. 100 ml you have taken, and that both are present. Then in that way you can understand the octane number of gasoline is the percentage volume of isooctane in a mixture of isooctane and normal heptane blend. Blend means mixture, which has the same knocking characteristics as the gasoline sample under test. Gasoline sample under test. Different samples are there. Maybe you can say octane number 30, 40, 50, 60, 70, 80, like that way. Then different samples are there. Then if it is 30 mixture in the mixture, if 30, you can say 30% or octane number is 30 is isooctane, 70 is suppose normal heptane, then octane number will be 30. If it is matching with 40, then octane number will be 40 isooctane. Okay, if it is matching with samples which 60, then it will be octane number 60 of that sample. Then like that way you can understand that the number of gasoline is the percentage volume of isooctane in a mixture of isooctane and normal heptane blend, which has the same knocking characteristics as the gasoline sample under test. The different gasoline samples are rated by their octane numbers. Higher the octane numbers of a gasoline, least is its tendency for knocking. But higher is the combustion, but higher is its combustion characteristics. 2,3 example I am telling you. 2,3 dimethyl pentane. What I told about the isooctane, that was the 2,2,4 trimethyl pentane. But now another example I am telling you, 2,3 dimethyl means carbon number 2 and carbon number 3, methyl means CH3 group is attached. Then that is called 2,3 dimethyl pentane. This is the example, has been assigned an octane number 75, means very good quality of petrol. If petrol whose octane number is 75, example is 2,3 dimethyl pentane. Correct? All petrol will not have same octane number. They differ. Okay, according to the knocking. According to the knocking, octane number will vary. Octane number less means it will knock more. Irritation sound will come. Irritating sound. Then this I have given example that 2,3 dimethyl pentane has been assigned an octane number 75 because it has the knocking tendency as that of a mixture of normal heptane and isooctane containing 75% by volume of isooctane. Means in mixture 75% isooctane was there and rest 25% normal heptane was there. It has been found that knocking tendency is largely related to chemical structure of fuels. The decreasing tendency of fuel to knocking is, few example I am telling you, a straight chain, its knocking is more. That is, a straight chain is greater than branched chain, and branched chain is greater than cycloalkanes, cyclic form, and cycloalkanes is greater than alkene. Cycloalkanes, it will knock more than alkenes, double bond, and alkenes will knock more than aromatic hydrocarbon. And this aromatic hydrocarbon will knock more than alkanes, single bond. Then this I have told about the, you can say, this knocking tendency. That what I told in the last, that has least knocking, alkanes, and first one straight chain was highest. Now then question arises, when knocking tendency is there, then how will you reduce? How knocking can be reduced? Then that is done by anti-knocking agents. Anti-knocking agents. What is anti-knocking agents? Now I am telling you. The use of high compression ratio in modern internal combustion engine, IC. In shortcut it's called IC engine, internal combustion engine. The use of high compression ratio in the modern IC engines demands gasoline of high quality. In internal combustion engine demands gasoline of high quality with least tendency of knocking. The octane rating of many fuels can be increased by adding of certain organometallic compounds to gasoline, also called doping, mixing. Okay. Just to increase the octane rating. The octane rating of many fuels can be increased by adding of certain organometallic compounds to gasoline, means petrol, and mixing is called doping. The substances added to motor or aviation gasoline for controlling and containing the knocking in IC engines are called anti-knocking. What is anti-knocking? The substances added to motor or aviation gasoline, means petrol, for controlling the knocking in IC engine. For controlling knocking in IC engines are called, IC means internal combustion engines, are called anti-knocking agent. Examples I am telling you. The common commercial anti-knocking agents used are tetraethyl lead, tetraethyl lead, that is in shortcut it is called TEL, tel. People will tell. That is actually tel, tetraethyl lead, TEL. That is the chemically it is known as lead, C2H5 whole 4. With the lead, 4 ethyl group is attached with lead. Lead is in the middle and 4 ethyl groups are there. 4 ethyl groups are joined. That's why 4 means tetra and C2H5 means ethyl group. That's why its name has given tetra ethyl lead. Shortcut TEL, tel. Also called tel. Okay. Then first anti-knocking agent is tetraethyl lead, tel, PbC2H5 whole 4. Second example is tetramethyl lead, that is the TME. Now in the place of ethyl group, methyl group is there, CH3 group. Third example is mixed methyl ethyl lead, means in that with lead, methyl group is also attached, ethyl group is also attached. That's why it is called mixed methyl ethyl lead. Among the anti-knocks, TEL, tetraethyl lead, that is the tel, is perhaps the most widely used, since it is cheap and more effective in increasing the octane rating of fuels. The normal dosage of tel, TEL, is 4 ml, you can tell, 4 centimeter cube per gallon of gasoline. Per gallon, 4 ml is mixed. Tel is mixed how much? 4 cc, cubic centimeter. Centimeter cube also you can tell. Or 4 ml is mixed per gallon of gasoline, per liter. Not per liter, per this the gallon you can tell. 4 ml per gallon of gasoline. It is normally used. It is not only for this you will use tel. Along with that, one more chemical is used. It is normally used along with ethylene dibromide or ethylene dichloride. Alone, tel is not used alone. It is used with ethylene dibromide or ethylene dichloride. What is its role? I will tell you. It is believed that, not believed, it is that during the combustion of gasoline, means burning, tel forms lead and lead oxide. During combustion of petrol, TEL forms lead and lead oxide. These species act as a free radical chain inhibitors, means it will stop the chain reaction. It will stop inhibitors. These are, you can say, free radical lead and lead oxide. These species act as a free radical chain inhibitors and thus curtail the propagation of explosive chain reaction. It will stop, it will curtail the propagation. Further reaction it will not continue. It will it will cut it. It will stop the further propagation. Further propagation it will stop. It will curtail the propagation of explosive chain reaction, because when a reaction will start, petrol will burn. It will continuously burn, but we want to stop it. Then how you can stop this burning continuously? Then that is done by this tail only, TEL. Okay, in that lead and lead oxide will be there. Then that is the main role. Lead and lead oxide, these species act as a free radical chain inhibitors, and thus curtail the propagation of explosive chain reaction, and thereby minimizing knocking. However, if TEL is used, the species lead and lead oxide may get deposited on engine parts and cause mechanical damage. Then sound comes from the damage upon the engine due to the lead and lead oxide. It will be inside only in the engine, and it will strike on the walls of the engine. That's why it will you can say harm the engine, mechanical damage. It will cause mechanical damage. Okay, in order to minimize the damage of engine, TEL is always used along with ethylene dibromide or chloride. What it will do? The function of this halogen compound, this bromide and chloride, what I told, that is the halogen. The function of this halogen compound is to convert the less volatile lead and lead oxide into more volatile PbBr2, means lead bromide and lead chloride. Actually, Pb and PbO, lead and lead oxide was in the engine. Now you want to bring it outside because it is harming the engine. Then this ethylene dichloride and ethylene dibromide is used. That will convert this lead and lead oxide into lead bromide or lead chloride. Then lead and lead oxide was non-volatile or less volatile, you can tell. But now lead bromide and lead chloride, it is more volatile, which escapes into air along with exhaust gases. This I told that now lead has come outside. When it came outside, then now it will create further problem, environmental problem, pollution. And whatever tears comes from your eye when you are sitting in the any auto or other bikes, then sometimes tears comes from the eye. That is due to the lead which is coming out from the, you can say, automobile exhaust gases. Then now I want to discuss about the unleaded petrol. Now you can understand the importance of, you can say, unleaded petrol. Means no, petrol should not have lead. Why? Now you have understood. Because lead is creating problem. It is harming to engine also and as well as environment also. Then due to that reason, unleaded petrol is used. Unleaded petrol means petrol will not have any lead. In order to enhance the octane rating of gasoline in internal combustion engine, gasoline is normally mixed with 0.1% TEL with gasoline. This increases octane rating by 10 to 15 point. If it is 50, then it will increase to 60 or 65, like that way. 10 to 15 point it will, this tail increases octane number by 10 to 15 points. Unfortunately, mixing of tail with gasoline brought advantage together with disadvantage. In order to overcome the harmful effects of TEL, it is slowly being phased out from the gasoline. Means it is phased out. They don't want. The gasoline, that is the petrol, free from lead is called unleaded petrol. Of late, it has become mandatory to use unleaded petrol for automobiles. The compelling reasons for using unleaded petrols are, now I am telling you. First, why it is now not want, you can say, leaded petrol. Now nobody want to use leaded petrol. Now it is mandatory to use unleaded petrol. But till date, people are using because it's somewhat cheaper. People are using leaded petrol. But it is mandatory to use unleaded petrol. What are the actually compelling reasons for using unleaded petrol? First reason, lead is toxic. Lead is toxic. The recognition of health hazard associated with its release into atmosphere from automobile exhaust led to mandatory phasing out of TEL in gasoline. Second, further factor for reducing TEL is a requirement of vehicles to be fitted with catalytic converter to control pollutants. Now every, you can say, automobile, maybe anything, two-wheeler, four-wheeler, they are using catalytic converter. For what purpose? Then to control pollutants. These gases, this converter, catalytic, name itself is their catalytic converter. A special type of catalyst will be used. That catalyst will convert poisonous gas to the non-poisonous gas. Correct? That is done by this converter, catalytic converter. A special type of catalyst is used. Then what will happen? Now every motorcycle or four-wheeler, they are using, every type of automobile, they will use a catalytic converter. Then leaded petrol, what it will do? Actually, this will work only, catalytic converter will work only when unleaded petrol is used. If leaded petrol is there, leaded, then it will not work. Okay. Only unleaded petrol can be used for vehicles fitted with catalytic converters because lead inactivates the catalyst used in converters. Means catalyst will not work in the presence of lead. It will inactivate the catalyst used in converters. Unleaded petrol rating, how will you increase? Suppose now petrol is free from this thing, lead. Then TEL you have to not use. Then how will you increase the rating? Octane number, how will you increase? Unleaded petrol rating can be enhanced by addition of certain compounds in place of TEL, TEL. What are that? The octane rating enhancer, such as, example I am telling you, TEL you are not using, then in its place what you will use to increase the octane number? Then first example is methyl tertiary butyl ether. Methyl tertiary butyl ether, MTBE. And other example is ethyl tertiary butyl ether. Both are butyl ether. One is methyl tertiary, and other is ethyl tertiary butyl ether, ETBE. Then along with petrol, what you are mixing, automatically drop by drop as per requirement you will mix automatically, but you are keeping separately. And with the petrol, what you are mixing, that is this only. Along with petrol, what you are mixing, that is this only, methyl tertiary butyl ether or ethyl tertiary butyl ether. Okay. And also others are also examples are there. Methanol, ethanol, which have octane rating. This I told you mainly methyl tertiary butyl ether and ethyl tertiary butyl ether. These are used for as an enhancer, means to enhance the octane rating, to increase the octane rating. And further, methanol, ethanol, which have octane number or octane rating above 100, octane ratings are also there, are added to unleaded petrol in place of TEL. Methanol, ethanol is also used. Few example I will tell you that which are whose actual number from 0 to 118 I will tell you. Octane number more than 100 is also there. Not it is up to 100 only. Then 0 I told you normal heptane. Octane number is 0. Third class means more sound, highest sound. This it will not burn. Okay, petrol will not burn. Whose octane number is 00. Late burning, late combustion. Second example, that is the methyl 3-methyl hexane. Its octane number is 52. Next example is ethyl pentane, 3-ethyl pentane. Its octane number is 65. And 2,3-dimethyl pentane, already I told you, 75. And 2,2,4-trimethyl pentane, already I told, 2,2,4-trimethyl pentane, it is 100. That is isooctane. 2,2,4-trimethyl pentane, that is a isooctane. Its octane number is 100. Now, further two I am telling you which is more than 100. Then benzene, its octane number is 106. And toluene, its octane number is 118. Then octane number above 100. How you are getting? Then 100 ml of isooctane plus extra you are adding TEL or now in its place other I told you this methyl tertiary butyl ether or ethyl butyl. How much you are adding, that you add, then you will get you can say enhanced octane number like 106 or 118. Means 100 ml isooctane plus x centimeter, x or by centimeter ml. It is not fixed, that you have to add. Then you will get 100 plus x. Correct? 100, 106 or 118. In case of benzene, 106. And in case of toluene, 118. Then now I am stopping only here. Next class again we will meet. Thank you.